Okay, so we're going to work through some more examples of solving quadratic equations by factoring by using this procedure. Get a 0 on one side of the equation if it isn't already, factor the side that isn't 0, set each factor individually to 0 in its own separate equation, and then solve those equations to get what x, or whatever your variable, is. Now, as I work through these examples, see if you can anticipate where I'm going. See if you can guess what my next step is going to be. And if you want to pause the video and try to think about that for a minute, or try and work out what the correct factoring is before I show you what it is, that would be great. That would be a really good way to get the most from this video. So first example in this video, t squared plus 11t plus 10 equals -8. It is a quadratic equation because it involves t squared. So we can't solve it just by getting the t term on one side equal to a number on the other side, because we also have a t squared term, and what are we going to do with that? So we've got our procedure. We want to start by getting 0 on one side. Right now there's a -8 over here. To get a 0 here, I'm going to add +8 to both sides. Then I have t squared plus 11t plus 18 equals 0. Next, I'm going to factor this t squared plus 11t plus 18. If you want to pause the video and figure out what the factors are yourself, now I'm going to tell you what they are. This factors into t plus 9 times t plus 2. Notice t squared plus 2t plus 9t, there's your 11t, plus 18. Next, I'm going to set each factor individually equal to 0. Give it each its own equation. So t plus 9 equals 0, or t plus 2 equals 0. And now I'm going to solve each of these. Subtract 9 on both sides, t equals -9. Subtract 2 on both sides, t equals -2. So there's my solutions. Next example, y squared minus 2y plus 3 equals 3. Do we have a 0 on one side? Well, no, we don't. We have a 3. How do we get rid of a 3? By subtracting 3 on both sides. So subtract 3 on both sides and you get y squared minus 2y equals 0. Now we're supposed to factor this. How do you factor something like y squared minus 2y? There's just two terms there, and those two terms do have a common factor. What can I pull out from these two? Y. So they're both y times something. Y times y minus y times 2. So it's y times y minus 2 equals 0. Now give each factor its own equation. Y equals 0 or y minus 2 equals 0. So y equals 0, that's pretty much already solved. That's what y is. It's 0. Y minus 2 equals 0. We want to get rid of the minus 2 by adding plus 2 to both sides, and then we have y equals 2. So the two solutions to this equation are 0 and 2. Notice we're always getting two solutions. That's no coincidence. The 2 power on the variable kind of is what makes it have two solutions. 0 squared minus 2 times 0 plus 3 does equal 3. And then also 2 squared minus 2 times 2 plus 3 equals 3. Next example, x squared plus 30 equals 11x. We want a 0 on one side. Right now we don't have a 0 over here, we have an 11x. So I'm going to subtract 11x on both sides. So now it's x squared plus 30 minus 11x equals 0. But this looks kind of messed up. There's nothing strictly wrong with it, but things are not in the order that we're used to seeing them. We have the constant term in the middle and the x term on the end. And we're used to having it with the x squared and then the x term and then the constant term. So it's going to be easier to figure out what the factors are if we have it in that order. So let's rearrange things a little. We're going to move the minus 11x to the middle and put the plus 30 on the end. X squared minus 11x plus 30 equals 0. Now we can factor. Pause if you want to figure it out for yourself. The two factors are x minus 5 times x minus 6. So for that to equal 0, either the x minus 5 equals 0 or the x minus 6 equals 0. Now, solve each one of these for x, add 5 to both sides, x equals 5, plus 6 on both sides, x equals 6, and there's our solutions. X could be 5 or 6. 4x squared plus 8x plus 4 equals 0. Now there is a common factor of 4 that I could pull out. After factoring out that 4, we got 4 times x squared plus 2x plus 1 equals 0. Now see if we can factor x squared plus 2x plus 1. And that turns out to factor into, you can either write it as x plus 1 squared, or you can write it as x plus 1 times x plus 1. You might have recognized this as one of those special patterns you have to watch out for. It starts and ends with a perfect square, x squared at the beginning, 1 squared at the end, and if you multiply those two things together, an x times a 1, that's 1x, and 2 times that would be 2x, which is what we have in the middle. So this is one of those perfect square trinomials. It's x plus 1 squared. But if you didn't notice that and you just tried to figure out, okay, what times what gives you x, what times what gives you 1, what gives you 2x in the middle, turns out the factoring is x plus 1 times x plus 1, which means the same thing. So now if we set each factor equal to 0, we get 4 equals 0, or x plus 1 equals 0, or x plus 1 equals 0. Yeah, I'm being redundant, but yeah. And remember, 4 equals 0, just disregard that. 4 can't be 0, it's too busy being 4. But for x plus 1 to equal 0, x would equal negative 1. And then this other x plus 1 equals 0, well, that would also give us negative 1. So here's one where we don't have two different solutions. We just got the same number twice. So the only solution here is negative 1. It just kind of showed up twice. Okay, how about this? Y squared equals 5y. Our procedure is start by getting 0 on one side. Right now there's a 5y where we want there to be a 0. So I'm going to subtract 5y on both sides. Y squared minus 5y equals 0. Next I'm going to factor the y squared minus 5y. There's just two terms here. What do they have in common? Common factor of y, I can pull that out. Y times y minus 5 equals 0. Now set each factor equal to 0 in its own equation. Y equals 0 or y minus 5 equals 0. So if y equals 0, that's a solution. That's a number y can be. It can be 0. If y minus 5 is 0, then add 5 to both sides and you get y equals 5. So our two solutions are 0 and 5. By the way, let me mention that what some people try to do with an equation like this is they think, oh, let's divide both sides of this equation by 5, and then y squared divided by y is y, 5y divided by 5 is, or 5y divided by y is 5. So if you divide both sides by y, that they both have in common, you just get y equals 5. And that's half right, but we lose one of the solutions that way because it's also possible that y could be 0. And if y is 0, then we're not allowed to divide by 0. So if you divide both sides of an equation by a variable like y, you have to worry about, well, could we be dividing by 0? If y stood for 0, then we wouldn't be able to divide by the y, so we got to consider that possibility separately. Okay, so on to the next example. 5x squared minus 14x equals 3. First thing to do, get a 0 on one side by subtracting 3. So 5x squared minus 14x minus 3 equals 0. Next thing to do, factor the side that isn't 0. Do you see a common factor we can pull out? Well, no. So this is going to break up into two factors that when you multiply them back out, like with the FOIL method, you get a 5x squared in front, you have a minus 3 on the end, and you have, when you combine the outside and the inside, you get a minus 14x. So it turns out that the correct factors are 5x plus 1 times x minus 3. I didn't show you how I figured that out. I had to do a little work behind the scenes, but that's what you get. And now 5x plus 1 equals 0, or x minus 3 equals 0. And then with 5x plus 1 equaling 0, first subtract 1 on both sides. Get rid of the plus 1 with a minus 1, so 5x equals minus 1. And then divide both sides by 5. Go from 5x to just x, undo the multiplication with division. So x equals negative 1 divided by 5, negative 1/5. Meanwhile, over here, add 3 to both sides, x equals 3. So the two solutions are negative 1/5 and 3. How about this one? 3x to the third power minus 10x squared plus 8x equals 0. Okay, this is kind of a bonus example because this is not technically a quadratic equation that just involves x squared. It also involves a higher power of x. But we can still solve this by factoring. Let me show you how. First, we need 0 on one side, and there it is. So we don't have to fix that. It's already got 0 on one side of the equation. Now, we want to factor the other side, the side that isn't 0. So I do see a common factor of x. All of these terms involve x, at least one x. So I'm going to plot an x, and then it's x times 3x squared minus 10x plus 8. Now let me see if I can factor 3x squared minus 10x plus 8. Pause if you want to see if you can figure this out for yourself. I paused while I was figuring it out, and I got 3x plus 2 times x minus 4. Notice if you FOIL this, you get 3x squared minus 12x plus 2x, so together that's minus 10x, minus 8. Now we have three factors. Each one of them gets its own separate equation. X equals 0, or 3x plus 2 equals 0, or x minus 4 equals 0. And now we got to get each one of these equations where it's just got x on one side equals a number on the other side. So this one already is like that. X equals the number 0. On this one, I would subtract 2 on both sides and then divide both sides by 3. So x equals negative 2 over 3, negative 2/3. And on this one, I add 4 to both sides, x equals 4. So the three solutions, hey, it involved x to the 3 power, and we got three solutions. 0, negative 2/3, and 4.